What if everything we know, and I mean everything, matter, gravity, the bizarre rules of quantum mechanics, what if it isn't a collection of separate things at all, but just emerges from one single, incredibly simple idea? Well, that's the core concept behind a new theory called the single bulk framework, and today we're going to see just how it plans to unify all of physics. But first, you might be asking, why do we even need a new theory? Haven't we pretty much got physics figured out? Well, not really. It all starts with a massive, glaring problem. Our best models of the universe, they can only describe about 5% of what's actually out there. The other 95%, it's a total mystery. We've just slapped on labels like dark matter and dark energy. Now, this isn't just a small gap in our understanding, it's a gaping chasm. And believe me, it's not the only problem. Our so-called standard model of physics relies on 19 magic numbers that we have to measure and just plug in by hand. We have no idea where they come from. Our theories of vacuum energy are wrong by a factor of 10 to the 120th power. That's not just wrong, it's spectacularly, cosmically wrong. And we still can't get gravity to play nice with the other forces. These aren't failures, though. They're giant, flashing neon signs telling us we're missing something really, really big. So here's the radical idea that sits right at the heart of the single bulk framework. What if space-time isn't just the empty stage where the play of physics happens? What if space-time is the play? What if it's a real, tangible, physical material? Now, this idea lands smack in the middle of one of the oldest debates in physics. On one side, you've got the geometers, like Einstein, who saw space-time as a smooth, continuous fabric. On the other side, you've got the atomists, who believe that deep down reality is pixelated, made of tiny, fundamental bits. And for centuries, these two views just seemed impossible to reconcile. This single bulk framework comes in and says, hold on, what if there's a third way? It says spacetime isn't fundamental at all. It's an emergent property. The best way to picture it is to imagine a vast cosmic sandpile. When it's loose, the grains can flow, almost like a liquid. When it's packed tight, it's a solid. This theory proposes that our universe exists right on that critical tipping point between those states, what's called a jamming transition, which lets it act like both a solid and a liquid at the same time. And this quote just nails the concept. We all know that water is made of individual, discrete H2O molecules. But when you have enough of them, you get the smooth, continuous flow of a river. The SBF says reality itself works the exact same way. A vacuum made of countless discrete grains at the tiniest possible scales gives rise to the smooth, continuous fabric of spacetime that we experience every day. Okay, so if spacetime itself is a material, then where do particles come from? Us, the stuff we're made of? This is where the theory gets truly mind-bending. It suggests that matter, it's just a feature of geometry. So get this. The theory says that particles aren't tiny little points or balls of energy. They are literal knots, tangled up defects in the very fabric of this vacuum material. And a particle's mass? That's nothing more than the elastic energy that's stored in that twisted up, knotted bit of space. This completely changes everything. You're not a thing that moves through space. You are a persistent, tangled knot of space. And what's so cool is that this isn't just a vague idea. The framework gets specific. It identifies the electron as the simplest possible stable knot you can make, a kind of trefoil with 3 crossings. The next heaviest particle in that family, the muon, it's just a more complex knot with 5 crossings. And the heaviest one, the tau, you guessed it, an even more tangled up knot with 6 crossings. Okay, I know what you're thinking. That's a neat metaphor, but is it actual science? Well, here's the kicker. This is way more than a metaphor. The framework provides a precise mathematical formula. It says you can calculate a particle's mass just from how complex its knot is. This is a direct, concrete, testable prediction. So they put their money where their mouth is. They took the muon, the knot with 5 crossings, plugged it into their scaling law, and it predicted that the mass should be 105.96 megaelectronvolts. Remember, this number comes purely from geometry and topology. There are no fudge factors, no magic numbers plugged in to make it work. So, how does that number compare to what we've actually measured in our giant particle accelerators for decades? It's off by just 0.28%. Let that sink in for a moment. A theory that starts with the simple idea that spacetime is a granular material ends up predicting a fundamental constant of nature with jaw-dropping accuracy, and it does the same for the tau particle with just 0.46% error. That is unbelievable. That incredible predictive power is amazing, but it's honestly just the beginning. The real payoff comes when you see how this one single core idea, this granular critical state vacuum, elegantly makes all those huge mysteries we started with just melt away. Just look at this. Dark energy? It's not some mysterious force. It's just the geometric frustration of all those vacuum grains trying to pack together perfectly, but they can't. Dark matter? It's a ghostant, a persistent plastic deformation like a scar left in the vacuum from ancient cosmic collisions. The four fundamental forces, they're not separate things at all. They're just different kinds of mechanical stress in the material, tension, shear, pressure, and so on. This right here visualizes the sheer elegance of it all. We go from the standard model, which needs around 19 of those arbitrary numbers that we have to measure and just accept, to the single bulk framework. It derives everything from just one fundamental parameter, which is basically the average number of neighbors each little grain in the vacuum has. And even that number isn't arbitrary. It's determined by the most efficient way to pack spheres in 3 dimensions. This is the difference between just describing reality and actually explaining it. So the theory explains the past and the present with this incredible elegance. But to be real science, a theory has to do more. It has to make risky, falsifiable predictions about the future. It has to be testable. And that, right there, is the soul of the scientific method. It's not enough to connect the dots we can already see. A great theory has to draw a brand new dot on the map and say, go look right here. If you don't find what I say you'll find, then my entire map is wrong. And the single bulk framework does exactly that. It makes some bold predictions. Right now, our gravitational wave observatories like LIGO are searching for echoes that would imply black holes have solid crystalline cores, just like the theory predicts. But the big one, the make or break test, is coming in 2032. A satellite called LightBird is going to launch. It will search for a very specific sawtooth pattern in the leftover radiation from the Big Bang. If that pattern is there, the theory is on solid ground. If it's not, the theory's dead. By about 2035, we should have a definitive answer. So, we end right back where we started, with this one radical idea. This framework asks us to see a universe that isn't made of particles and forces happening in an empty void, but one that's made of a single, unified substance, a vast granular material sitting at its tipping point, whose vibrations, knots, and stresses are what we perceive as the whole of reality. It's a profound shift in perspective, and with real, concrete tests on the horizon, it might just be the next testable revolution in physics.